Cool. So at the very core of programming, there are three control structures: sequencing, branching, and looping. Pretty much everything in code is built out of these three pieces, right? They're really simple, but when you layer them on top of one another, you can get really complex behavior. Games are no different. Games are made out of just those three structures. And so I'll just go through them quickly. Sequencing is just a program executing commands from top to bottom. That's how all programs work at the core, is there's a list of things. You can't see my screen. Interesting. Can you see it now?
Yeah, you're sharing now.
Sweet. Okay. So computers run things in a sequence from top to bottom. I think the example people always use is, list the steps you take in the morning to get out of bed and go to work, right? I put my leg out of the bed, then I put my other leg out of the bed, then, I get dressed, then I go to the bathroom, etc. And that's a linear sequence of actions. It happens one after the other, right? Branching is making a choice. So there's a question that's asked, like, should I do this or that? And that determines which sequence runs, right? So people who have a little bit of coding experience might know this is an if statement. If this, then do that, else do this. And then looping is just running a sequence a number of times based on a branch or a condition, right? So while a value is true, a loop runs over and over, running the same commands over and over, right? And so that's all programs. These are the three components that make up every program. And games, like I said, are no different. These are the fundamentals we have to work with for simulation. In Unity too. So in kind of pseudocode, there is a loop. While quit is not pressed, we get the user input, we update the game based on the user input and the time that's progressed, and then we render an image based on the current state of the game. The time and the user input affects the game, and then we render an output from that. And then that loop continues. And that's the game loop. That's how all games work. It's just a sequence of commands executing in a loop. Getting user input, updating the game state, and rendering an image based on that. And so Unity abstracts that a little bit. They do a lot of the legwork for you. But in essence, it is the same thing. So this is a valid Unity script. It'll compile and run in Unity. And you can see here, there are these three sections in between these curly brackets. Start, update, and destroy. And these map to before the game loop, during the game loop, and after the game loop. Update runs once a frame for every loop of the game loop. On destroy runs after the game loop, and start runs before, like I said. So hopefully this gives you context to understand how Unity scripts work and how they're really just based off simple programming concepts. There's no black magic going on behind the scenes. It's a loop and it runs multiple times. Each time it runs, it renders one frame. Does that make sense? Does anybody?
Yeah.
Yep.
Making sense to me.
Sweet.
Same here.
Yeah, winning. Okay, cool. So that comes to the end of kind of the overarching theory. And now we're going to use that knowledge to build a little example in Unity. Like I said, you don't have to if you don't want to set up all the do all the legwork to set up. It is a pain, but if you do, that would be awesome too. So I'm going to let anyone who wants, I'm going to assume that anyone who's wanted to do this has already set it up. If you haven't and you want to, there is a project setup page over here that just lists the basic steps you need to do to set up a Unity project. And then we can move to the exercise, right? So first of all, let's just run through what the complete scene looks like, what we're heading towards. Charlie, you wanted to ask if everyone's ready?
Yeah, I just want to check, is it anyone who does want to set up, do you want to take a few minutes to set up, or are you happy to go forward? Let's just take a second to let those type. Okay.
Sweet. Yeah,
So
there's no rush.
If we can circle back.
Cool, sounds good. Well, for now, so I'm just using the Unity default third-person camera controller. But you can see here, there is a ball going up and down. And that's what we want to do. We want to use the basics of the game loop to cause an object to move, right? And so this is what the example project looks like. And so you can just download that and run it and basically see the code we're going to end up writing, the values in real time, and how that relates to the object moving, and then some of the math that we're using to achieve that. If this looks overwhelming, it's more information than you'll ever need practically. What we're actually going to do is very simple. But this is just, if you need to know anything, it's all here, and you can just check it out. So, are you ready? I would like to wait for you, if possible.
Ross, can I ask a quick question?
Yeah, go for it.
Like, where in this example, does anything come to mind in terms of games that we've played, like, or that some of us have played, that we would see this type of example in a game, like creating this, just kind of a practical in-game example? Does anything come to mind?
Yeah, well, so practically, every time something moves in a game, a player or literally anything, a bullet's a great example because they generally just move linearly in one direction, right? They go from A to B at a constant rate, or a ball or whatever, right? Like in Rocket League. That's all using an update loop. And it is essentially doing the same thing, moving from point A to point B. So in terms of context, obviously this is programmer heavy and it's not, it's not directly related to any specific game, but it's the basis of all games, right? There is an update loop that runs and does basic commands over and over and over. After those commands, it renders based on the updated state of the game and continues. I don't know if that helps clarify or contextualize.
Oh yeah, gotcha. I think that Rocket League example helped a lot.
Awesome, yeah. I mean, if this was Rocket League, it would be a terrible game. So luckily, it's not. But it could be the start of Rocket League, potentially. Okay. Yeah, Brian My Brewery, great example. In this stunning game coming to all platforms near you, there's a roll that runs right across the screen at a constant rate, right? That is just a case of moving the object every frame a little bit to the right. So we'll get into that. So whoever's following along, double click on the work scene. This is where we're going to be working in this example. It's a duplicate of the other scene, except some of the code has been removed so that we can add it ourselves, right? Underneath this, there is a bouncing sphere. So in the hierarchy, this little bouncing sphere over here, there's a bouncing sphere script on here, and the script is empty, right? So let's go through some of the basics of Unity for those who are not familiar with them. This is called the project window, and it serves as a file explorer, like Windows Explorer, right? It just shows the files that are in your project directory. And it is where we find our scenes, our scripts, anything else essentially that isn't directly in the game world. Everything in the game world we find in a scene, so in the work scene, for example. All scenes are made of these things called game objects, which is basically just a grouping of a position and a name. So we can see here there is a game object which is called example1, and it has a position over here and a name, example1, right? At the very root of games in Unity, and pretty much most game engines, they have this concept of an empty object with a position. And so a lot of the game logic we write relates to how we move these game objects around in relation to one another, right? Or in relation to the origin of the scene, if they're kind of at the top level of the scene. So, you know, the origin of the scene is over here. This is 0, 0. Charlie asks, what is an empty? Is it just a thing to store those parameters? Which parameters?
Like, for example, position, rotation, and scale. So is it just a data point, basically?
Yeah. In essence, it is position, rotation, and scale, right? At the very least, it is a reference point, you know, a point in space that we can look at and know that it's 10 units away from where we are, for example. And so these empties with this position, rotation, and scale form the basis of all game programming. That's how we relate objects to one another through what's essentially very simple math and distance calculations. But game objects can have a lot more functionality. And the way they're done is by adding different components to to the game object. So each game object will always have a transform component with a position, rotation, and scale, but they can have additional components, like in the bouncing spheres example, a renderer that renders a sphere, right? And we can see that in the scene view over here. There's a sphere. So as things get more complex, you'll have more and more components with additional behavior beyond just position. And so that's how we program in Unity, is we add scripts as components to game objects. And then those scripts run logic on that game object, that position, rotation, and scale, and whatever additional components we have. And so for this example, we're going to be accessing the example1 bouncing script on the bouncing sphere game object. And so when everyone can, open it up.
So a quick question. Can you go back to Unity for a second there?
Sure.
Why, like I see you've got example1 and bouncing sphere parent and bouncing sphere, and you've got the script on that last one. Why the need for such a stack? You know, like why not just make a bouncing ball and put the script there without parenting it to its parent or the example1? Is it just for neatness, or is there like logic behind like it being a child of a parent?
Yeah, so it's for both, I suppose. The example1 game object is just an empty that's used to kind of set the reference point of the example a bit closer to where it's actually happening, right? The origin's set over here, in this corner, and I just wanted to move it a little closer. So we're just working kind of within a local space, right? So that's just kind of for convenience and just housekeeping, I suppose. But then the bouncing sphere parent underneath it is kind of we don't want to have to operate in the global space of the scene because we don't have enough context to really know where the bouncing sphere could be bouncing relative to. You know, if I choose to duplicate this bouncing sphere, right, it's going to set its transform to the same location when we run code on it, the way the code's set up. So it's possible we could write code that would account for the different starting positions. But in practice, what will happen now with the script is they will all be set to 0 and start moving kind of overlapping, right? And so that's because we're setting the local position of that sphere. But by adding a parent, we can move the parent around, and the local position of both of these spheres is the same, even though they're in a different space in world space.
Okay, that makes a lot of sense now.
Cool. Yeah, so we don't need to do this. You could argue it's more complicated, but I would argue that it simplifies the code because we don't need to worry about the world space. We just use the local position of the sphere, and then if we want to move it around, we just move the parent around and the code stays the same. Don't need to store, where it started or anything like that. But I mean, it's an option to not have the parent. Just in this case, I thought it would simplify the code a bit for this example. Cool. So before we get into the coding, does anyone have any questions, confused, bored, wants to tell me I'm wrong, anything like that? Or you can tell me I'm right. I don't mind. Yeah.
You're so right, Ross. You're so right.
Hell yeah. Okay, I'm just going to check Ops is recording things properly. It might be, who knows. Okay, so awesome. Okay, that's really good to hear. Cool. So like we talked about before, a game loop runs the update every frame, and so whatever code you put in here will run every frame, right? The problem is that computers don't care about how fast those frames run or not. The computer is going to run as fast as it can and render and calculate everything as fast as it can. And so if we don't program carefully, we're going to create a game where everything moves faster on a faster computer and everything moves slower on a slower computer. And I wish this was just like a theoretical problem, but they've released games. It was one of the old Need for Speeds that when the frame rate changed, the game sped up or slowed down. And that's pretty bad. So in general, we want to program so that even if the update loop runs really fast, the ball moves at a constant or expected rate. And the way we do this is by using time. If we can get the current game's time, or the world's time, or the real world time, or any time reference that is not linked to how fast your computer is running, we can start to move objects around without needing to worry about how fast your computer's running. If a ball takes 1 second to go up and 1 second to go down, if it renders 1,000 frames or 2 frames, the movement will be the same. It might look more choppy if your computer's running slower, but it's not going to affect the movement of the game. And that's really important when you don't want a game to gameplay to actually change based on the computer. And so that's what we call frame rate independence. And that's kind of the core of what I wanted to get across today, is using time to move things enables us to build code that runs and moves things on any computer at any speed. And so let's get into that. First things first is if we go and type debug .log and just put in here time. This is going to output the current game time to the console. And so in Unity, the console is most of the time somewhere over here in the bottom kind of middle. And running this work scene now, the ball won't move because we haven't coded the ball to move, but we're going to get, hopefully, when the game decides to run. While we're waiting for this, does anyone have any questions?
Yes. Sorry, Ross, I have a very stupid question. How do you get your coding thing to look all colorful?
Okay, so what coding thing are you using?
All Visual Studios, I assume.
So in Visual Studio, is there anything that looks like this where it says attached to Unity Editor? Does it mention? No. Okay, so potentially what's happening is Unity Visual Studio plugin. There's a plugin for Visual Studio that connects Unity and Visual Studio together. And when you install that and whatever prerequisites that requires, it should be able to connect to Unity, and it'll also do the syntax highlighting as expected. The fact that it's not doing syntax highlighting makes me think that you might not have C# prerequisites installed. But regardless, whatever Visual Studio is doing, Unity compiles the game separately to that. And so you should be able to still write code and have it run in Unity.
Okay, awesome. So even if nothing's in color, it should still work if I type what you type.
Yeah, hopefully. I mean, programming's never that simple, but that's the theory.
Okay, and second stupid question. Do capital letters like matter? So like, do I need to capitalize that first time there, or the debug, or the log?
Yeah, that's a good question. Yes. So I think it's possible some languages might not care about that, but almost always across the board, capital letters do matter.
Okay. Thank you.
Sure. So we are outputting the current game time to the console, right? You can see here in the bottom left corner, hopefully, there's a time. Currently we are at... Yeah, so C# uses camel case for all variables except public variables normally. But depending on who you ask, they all have different opinions. I mean, this is like when you get into programmer wars where people are fighting over white space. I'm personally of the opinion that if it works and runs, then we're doing good. And especially if we're wanting to create art, then whatever gets the job done. But yeah, so okay, so now we're at 180 seconds of game time, right? And so I'm just going to unmaximize this quickly. If I can figure it out. Oh no, there goes my mouse. Come back.
Yeah, I don't think... there we go, sorry. Is that at the bottom left? It's showing the game time. Gotcha, never mind.
Yeah, so the bottom left, or now at the console, we have the game time shown. And so I'm just going to turn collapse off here, right? We have over 999 messages that have been sent so far, and more keep coming. And there is a single log for every frame because update runs once per frame, right? But for every frame, the actual time getting output is separate to how many frames are running. if this was running at 2 frames a second, it would be the same time as 200 frames a second. Although there would be less logs, the time would be progressing at the same rate. And that's kind of the core of how we make things move at constant rates across the board in programming. So now that we've hopefully understood this, the next step is to go back into our code editor and make something move based on this time, right? So what we can do, I'm just going to comment this out with 2 forward slashes just to keep it there if we need it. We can access the components on this game object or through this script. And there's a lot of sort of properties that we just have access to in any Unity script, and so one of them is the transform. That's the same component we saw in the top right-hand corner of the inspector here for any game object. It has a position, rotation, and scale, and it's accessible through code as well. And so if you just type transform, that's a valid object, and we can get the position or set the position. And in this case, like we were talking about earlier, we want the local position of the object. And so if we set the local position to 0, 1, 0, and run this, okay, well, the ball is over here before the script runs, and when the script runs, when you press play, it jumps up a unit, right? 1 unit in Unity is 1 meter. That's different in different programs. I think Unreal uses centimeters. I mean, I know different 3D software have different units and what they mean, but in Unity, 1 unit is 1 meter. And that's important when you get into the finer details of, physics and weight and things moving around and hitting each other. But for our purposes now, we just want to know that, because if 1 unit is 1 meter, that means that if we put time into the Y position of the ball, we will get a ball that moves upwards at 1 meter per second, regardless of how fast the computer's running. And so let's test this theory.
Yes.
Okay, that is way slower than 1 meter per second, isn't it? Surely not, right? Is it? No, maybe it is 1 meter per second. It's hard to tell. There's no frame of reference. But we have a balloon by
floating up to the sun. Amazing.
Yeah. What was it? The fable of Sisyphus?
Icarus.
Icarus. Yeah.
Hold the boulder up a hill endlessly.
Yeah, of course. Okay. Well, there's a similar sort of, yeah. Yes?
I've got another question. If you go back to your script stuff,
yeah,
that stuff in the beginning, before we got into the code, is that just default always there? Like when we edit a new script in Unity, will that stuff be there already, or do we have to put that stuff in?
Yeah, okay, so it's a little different from a default Unity script, only because I have the complete example and the kind of workbook example that we're using, and they have the same name. So I had to make some modifications that you can have 2 scripts with the same name, but that's really not important in kind of the context of your question. Like if I go to a random game object and I can say, my new script, right? I can add a script there, and once that script is added, right, it gets added to your project view, so it's on the hard drive in a you could find it on the Explorer, this script will have a default setup that looks, I mean, literally like this, right? Whee! Yeah, bye balloon.
Cool, yeah. That makes sense.
Cool. So, I mean, it's a little different, but in essence, as long as, like, if you type debug.log or whatever in the update loop, and it's on a game object, it's going to log or do whatever logic you want, right? And then, yeah, obviously start comes as well, and that's kind of will run before the kind of game loop starts running. Yeah. Cool. Just going to remove my new script for now. Cool. Does anyone have any other questions? Getting stuck on something? There are a lot of things that... What's the difference between start and awake? Okay, that's a good question. So you need to often in Unity, from one script, you want to get some information about another script. Maybe it's just a reference to that script to use it later, or maybe for whatever reason you might want to access another script. And there's a problem where you don't know if that script's start has been called or not when you access it. So you're not sure if it is ready to be used, basically. And so you separate scripts into, let's go back here, public void start and void awake. So you separate the script into two different sections. One is I'm ready, and one is I'm only going to do my private stuff that doesn't require any outside dependencies, right? That is not valid code if you're wondering. But basically, the wake method is for handling your own setup. And then on start, there's this kind of shared understanding that when start is run, other pieces of the game are ready to be accessed. Some of those pieces are code that you've written, and some of those are Unity's game systems that are only ready to be used on start. So awake always runs before start, but awake shouldn't really access the outside game world just yet. But when start runs, the assumption is that that's safe to do so. So they basically do the same thing for all intents and purposes. It's just that awake runs before start. Yeah, hopefully that clarifies a little bit. Sweet. Sorry if that was long-winded, but yeah. So getting back to our balloon, right? This is essentially the simplest version of a frame rate independent movement that you can have in a game. And so obviously we don't want a balloon that flies up into the sky forever, right? So we can use time with other math or logic or code to make sure that our movement code is frame rate independent. And so the simplest way we can do this is by, for example, I could say public float speed equals 1, right? And so this is just a value of well, let me make it private actually, so we can stick in the code editor for now. This is just a value of like how fast it will move. And so if we multiply time by speed, now if speed is 1, the balloon will move at 1 unit per second upwards. If speed is 2, it'll move at 2 units per second upwards, right? And so using time, we can start to change how things move while keeping it frame rate independent. And another thing you can do, which leads us to our bouncing ball, is to use sine. So I don't know if anyone is uncertain about sine or how it works, but it essentially is a graph of kind of a wave over time. So it looks like this. Let me find you an example. Yeah, there it is. So that's sine, and it is a constant wave that goes from 0 to 0 and then repeats infinitely as the x value increases. And so if we use the x value, if we use that, if we use time as the x value, right, then we can put time into a sine function and get out a value that increases and then decreases and increases and then decreases over and over. And so that's what we've done here. And the output is a value that if we plug it into the position of our game object and then run the game, we get the ball floating up and down like a good little ball, right? And that sort of concludes the kind of prepared part of the tutorial. So if anyone has any questions or comments or needs any help, just shout.
I have one. This is my first time doing any sort of code ever. What is a compiler error?
Nice. Yeah. So the computer tries its best to understand your intention and then make that intention happen, right? But it's not very good at ambiguity, right? And so when it doesn't understand something, it'll throw a compiler error and try to point you to what it's confused about.
So I've typed something wrong in my script.
Likely. I mean, you can, I don't know, maybe compare or otherwise share a screenshot of your code and we can look at that.
No, it's okay. Thank you. I'm going to sit here and mess with it. It's fine. Thanks.
Cool. And the number one thing generally is that people forget semicolons at the end of their lines. Yeah. So yeah, check that.
Thank you.
I've got another question. Sorry, it seems like I'm asking a lot here, but
that's great.
To get the ball bouncing kind of as if it were to like hit the ground and then bounce up again and then hit the ground and bounce up. I imagine that's a lot more complicated because it's almost takes into account like physics or what do you call a collision or stuff like that. Is that fairly easy to explain, or does it get pretty wild?
Yeah, I mean, so like ironically, there are certain affordances that game engines have that make things very easy to do because they're all kind of done for you, and physics is one of those things, right? So for the most part, the problem is if I did a bouncing ball like you're describing, we wouldn't have to code anything. So it's very easy. I mean, I can show you. It'll take a literal second. Okay, that's not true. Not a literal second, but very close. So let's say we just grab this.
Don't have a promise, trust.
Yeah, I realize. So bouncing sphere physics, and we add, okay, remove the bouncing script from it and add a rigid body. This is like the physics component for Unity. We have created on Play well, it's not very bouncy, but it is a ball that has physics, and you can see it falls when you move it around. Yeah, if you had to put it on a slope, let's see if I can get it on a slope here, it'll roll. So that has angular momentum too, and that required no code. If you wanted to make it bouncy, you can, I think there's a way to, create something called a physics material, call that Bouncy Ball. It's not spelled correctly, but I'm just going to run with it. Make bounce combine maximum, bounciness 1, grab the sphere collider, and on the material there, drag that material into the sphere collider. And when we play this again, we now have a bouncy ball.
Pretty damn cool.
Yeah, and I mean, you can. We actually.
Who needs coders when you can just do this stuff?
Right. Yeah, coders.
Coding's dead.
Down with coding. Yeah, I mean, we actually are kind of ironically recreated Rocket League here. It's quite fun. Yeah. Okay. So there was a question. Can you change the strength of gravity? You can.
I think you can.
Yeah. So the simplest thing you can do is just turn gravity off in a rigid body, right? But that's not strength. Mass obviously is independent for the most part of the acceleration due to gravity, which is a constant rate. So that is a project settings thing in physics. You have, so just to be clear, I did that a little bit fast. In File, Edit, Project Settings, there's a physics option here, and gravity is a value in there. So that's set project-wide. For 3D, for 2D, you can actually change the gravity multiplier on individual objects. But with 3D physics, it's currently it's set to 9.8, but you can make it anything. Yeah.
Awesome.
Yeah, Unity's interface is like 90% of the battle. So I'm glad that helped. Yeah. Anyone have any more questions, or are we gonna wrap up?
Question.
Shoot.
Would you be willing to do another session?
Yeah, so presuming that this people found this useful, I would like to kind of build on this understanding of time and how it's used in code, because the next step, if we go back to this original kind of preamble, is to get user input and then use that user input with our understanding of moving objects frame rate independently to start creating games, right? Like a simple game could be Pong, for example, which we're halfway to creating, to be honest.
Do you recommend one practices these ideas that you've taught us today?
Practice? How? Or how do you recommend?
Yes, kind of solidifying the fundamentals that you've kind of shared.
Cool. Thanks so much. It was really nice of you guys to join. I'm really, really, really stoked. yeah, so do something that's fun, and don't do something that's big. Big games and big projects kill motivation, and it's really important to do something that's within your kind of grasp, because making a small game like Pong, for example, is going to be so much more rewarding than throwing yourself in the deep end trying to create, World of Warcraft, getting really excited and then getting really demotivated when you realize that it's just so much work. And that's not a result of anyone's inability to do something. It's just a result of time. And small projects make me happy. So that's the route I would go with.
Of like a super simple one, would it be like 2 inputs, and like if you had to describe one right now, how would you describe it?
Two inputs is a great example. I mean, build games that already exist. So Pong, Snake, Snake's great. It's actually relatively complicated in comparison to Pong. But Rocket League, where you, play against a friend on the same controller or something. But I mean, I guess whatever makes you excited, really. It's the biggest thing.
Cool. Does anyone have any other questions?
Not a question, but more just a comment on, like, I completely agree with that whole starting small and not trying to build things. Like, I remember at the beginning of last year, I tried to build like a multiplayer game, not knowing how to code, and it was just 12 months later, pretty much, I was like barely any further ahead than I'd started, and it was such a demotivator, like such a killer of inspiration that. The funny thing is, I thought I was building something small, but I think multiplayer just absolutely destroys like simplicity. It gets so complicated building a multiplayer game, or at least in my experience, it was. So I just kind of second that notion of build something really small to start off with.
Yeah, I think it's just, there's so much depth in very simple things that you can find and polish. And to have the opportunity to do that versus like getting stuck in like, oh my God, how do I do everything? I mean, I third the notion that I first did and you seconded.
The other big thing was, because I was so scared of code, I started doing everything in visual scripting, which is in Unity. There's a program called Bolt, which it's a kind of drag and drop visual scripting tool. But that ended up like compromising ability to do stuff later on. In the beginning, it was amazing, but then as time progressed, it became increasingly difficult because there just wasn't a lot of resources out there to like help with errors or problems. Are you like, as a coder yourself, is visual scripting something that you kind of encourage people to start on, or do you think it is actually better to just go straight into text-based coding instead of visual scripting?
I don't really know. I mean, Unreal has built a pretty healthy ecosystem and a whole suite of really good games, which is largely based on visual scripting. And that's enabled kind of less technical people to do some really cool stuff. And it's also enabled a lot of artists who have technical background or technical inclination to become more technical, right? It really depends. It sounds like with Bolt, you ran into a situation where it was just like a very little information and help available, and potentially maybe Bolt wasn't as fleshed out and sort of error-free as you would have hoped.
Doesn't it also depend on who's working in that platform? Because for me, I would rather use Unreal, but because everyone I know is working in Unity, I've just chosen to get to know Unity better.
Yeah. Yeah, well, that's a really good point because I mean, if you want to work with other people, the likelihood is a programmer coming on board who has to face both would be terrified, and you know that there's a lot to be said for just using the tools that everyone else is using.
Yeah. I mean, remember we tried to do this game jam where someone knew Unreal and you were trying to learn Unreal while we're doing a game jam.
Yeah, yeah, that was. I mean, that was great to learn Unreal, but also, yeah, the friction with learning new things and communicating with people and their understanding is really important. So, I think whatever everyone else is using. Sorry, if this didn't fully answer your question, Rich. I think it's a.
No, it's perfect. Yeah, thanks. And thank you for hosting this. It's really insightful.
Cool. Yeah, I hope it helped you guys.
Thanks everyone for joining, and thank you, Ross. Before everyone heads off, I just want to know, would you guys be keen to have another session? And if so, do you think that in 2 weeks would be enough time, or would you want in a month? Just want to get some ideas. So, Rich?
I'm just checking out these noodles that Ross is Googling. 2 weeks is good for me, I think. I think it's a healthy gap between now and then.
Yeah.
But
thank you. And anyone else who would like to join again?
Sarah seems keen.
No, I'm keen. I need to go and learn a lot more about coding before I join the next one, though.
So there were a lot of general programming basics that I skipped over for the sake of focusing on how games work specifically. If anyone has any questions about any of those, please feel free to just message me on Discord, wherever you want to contact me. Obviously, I really like the stuff, so I'd love to help out if I can.
So instead of maybe messaging Ross, maybe also ask on the C# and Unity channel so that everyone else can kind of benefit from seeing what kinds of questions are being asked.
Yeah, that's a fair point.
Thank you everyone for joining. It's really been rad having you all come from the Renderhead side and Richard from the Game Jams, and I think Chris is from the Renderheads UK, so that's rad. We have an international visitor on the server.
Yeah, thank you so much.
Yeah, thanks guys.
Cool. Good night, everyone.
Ciao.
Thanks, guys.
Good night, guys. Thanks so much. Cheers.